So welcome, and today we'll be learning about quadratic equations. You all must have seen prior videos about quadratic equations. Today you'll learn a different method to solve them. It's known as completing the square. So as you all must have all learned initially, the two basic ways of completing a square are as follows. So a plus b the whole square gives you a square plus 2ab plus b square, and a minus b the whole square gives you a square minus 2ab plus b square. Now using this in a quadratic equation. So for example, if we have a quadratic equation such as x square plus 6x plus 7, you basically compare each term. So you will first compare a square to x square. So if a square is equal to x square, that means a is equal to x. Your second term is 6x to 2ab. So 2ab is equal to 6x. You know that a is equal to x, so you can substitute that here. So 2xb is equal to 6x. So b here is equal to 3. So once you have these two terms, you know you can easily find out the entire quadratic equation. So that's x square plus 6x, and you know the last term is b square. So if b is 3, you know that b square will be 9. So you have plus 9. So this becomes your entire squared equation. As it's given as plus 7, you just subtract 2, which is the same as x square plus 6x plus 7. Now x square plus 6x plus 9 can be written in the form of x plus 3 the whole square, and then you have minus 2 on the side. Now to solve this for x, your equation should be equated to 0. Now basically you have to make x the subject of the formula. So you follow 3 simple steps. And there you have your values for x for this particular equation. So that's the method of completing the square. Another example would be for the negative quadratic equation. So for this, it would be kind of a similar approach. The only difference is you will use a minus b the whole square as your formula. So as you know, a square is equal to x square, so a is equal to x. And in this case, b would be equal to 4. Negative 4 and negative 4 square is 16. So you will just subtract 3. So it would be the same method that I've used here to find the value out for this.